Okay, so the next topic is writing your own value returning functions. So as we have already understood that value returning functions will end or will return something after the execution is performed, right? So these statements will end with the return statement. So it should be return if you are returning anything, followed by whatever that you are returning. So the format is return space expression. The value for expression will be returned to the part of the program from where it has been called. So we'll see that example. You can also return multiple arguments. We will also see that in the next examples. So let's take a look at this. Let's say you are calling the function sum somewhere, and when you are defining the function sum, you have defined sum num1, num2. Num1, num2 here are called as parameter variables. If you have guessed that right, then you got it right. So num1, num2 are called as the parameter variables, which are basically taking the data from the arguments which you are giving when you are calling this function. So in the next line, you have result is equal to num1, num2, return result. So let's say you are creating a variable that is total is equal to sum, open and close parenthesis. So total is a variable that is calling this particular function. So the result will be saved in that total variable. We'll see with a better example that's in the next slide. But you could also return expressions like this. Num1, num2, you can just add them and then return the entire expression, which will be basically the sum of these two numbers in this case. So let's take a good look at this example here. You are first defining the main function, and inside that you are asking the age. So first age is input your age, second age int input, enter your best friend's age. Then you are adding these two ages, first age and second age. So you have created the variable total is equal to sum. You're calling the sum function with the arguments first age, comma, second age. Next statement is print together your total years old. So when you are defining the sum function, you have the same function name, right? Because if it's a different function name, then it doesn't work, because it will just throw an error if that function is not defined. So you are going to use the same function name, sum, comma, some open parenthesis, and then you have num1, comma, num2 as your parameter variables, which will be having the data of first age, comma, second age. So num1 will be first age, num2 will be second age. We already know this. This is called as pass by value. Next, result is equal to num1 plus num2, return result. So this result, which is the sum of num1 and num2, that is will be stored here total, because we do know the working of the interpreter when using functions. So the interpreter will first start from here. It will go here. Total is equal to sum first and second age. So yeah, so when the interpreter is starting, like let's say this is your entire program, right? So the interpreter will be here. It will first execute everything. It will not print anything. It will not perform the operations. It will first compile everything. It will not execute everything. It will compile everything. And then once it hits the main statement, that is main, open and close, this is where you are calling your main function. So from here, the interpreter will jump back to this position, and now it will start executing, because this is where you are calling your main function. So you're calling the main function, and so first age, you are getting the data from the user. Second age, you are getting that from the user as well. You are calling your sum function. So the interpreter from total will jump to the defining part of the sum function. It will perform the result. As you are returning that result will be stored in the variable total. And then in the next line, the together you are total years old will be your last statement of your program. So let's say the first user has entered 22, next is 24. With first age being 22, second age being 24, that means our num1 is 22, num2 is 24. You are adding those two, which gives us to 46. And then you are returning that result, that is 46, to the variable total. And then the last statement will be together you are 46 years old. That is how this program is structured. I hope the program structure and how to write your own value returning functions is clear. Okay, now let's see how to use these value returning functions. So we could use them for simplifying mathematical expressions. Also, we could use in complex calculations and use the returned value to assign it to a variable or use as an argument in another function as well. So we could take that value and then calculate the average, let's say, because for average, we need the total number of items divided by the number of items that we are calculating the average for, right? So you could always take that value and pass it as an argument to the next function. So here is a different example. So first, you are creating a global constant. As I've mentioned before, global constants should be in all caps. So discount percentage is 0.20. It is in all caps. So when the programmer, looks at this, he will understand, he or she will understand that this value is fixed, that you are not supposed to change this discount percentage value. So inside your main function, you have your regular price. You are calling your get regular price, sale price, which is regular price minus discount of regular price. So you're basically calling your discount function with regular price function. So notice this, your regular price will have some data that you are getting from the get regular price. So from this, your get regular price is a value returning function. And this regular price, which is now containing the value that is returned from the get regular price, is passed as an argument for the discount function. So after this, the sale price will be your final output. So when the interpreter is at regular price, it will jump to get regular price. And here you are getting the data from the user, you are returning that price. So the returned price is equal to regular price, right? This price is saved in the variable regular price. Now this regular price is being sent to the discount function. So let's say the user has entered the terms regular price is 100. So this 100 is stored in regular price. So now our regular price is equal to 100. We are passing 100 as an argument for our discount function. So when the interpreter is jumping to the discount function, it is price times discount percentage, which is our global constant. So it can be accessed from anywhere from the program. And also notice this, the global constants appear first, followed by the defining of the main part. So these are outside the main functions. So now you are taking the price that is 100, multiplying that with 0.20, that will give you 80. That is basically 20. Sorry, my bad. So you are taking that value 20, and then that will be the output of discount of regular price. Notice discount of regular price is not assigned to any variable, but the output of this function is still 20. So after this statement is executed, like sale price is equal to 100 minus 20, which is equal to 80. I hope this program is clear. If not, I would ask you to just go back to the lecture again, rewind, and then replay the lecture. We could always use IPO charts to determine the flow of the functions. So describes the input, output, and processing of a function. This is used when you are trying to document the functions as well. This is typically laid in the columns. Here there will be brief descriptions, unlike the hierarchy charts. So here is an example. So get regular price function will have input, processing, and output, because each and every block has that input, output, and processing. Input is none, prompts the user to enter the item's regular price. That is your output. So basically input here is the argument or the parameter variable. As you are not feeding any arguments to this function, the input is none. For the discount function, you are feeding some data, that is your regular price. Next, you are performing the calculations, which is the processing part, and the output is a discounted amount, or the output of this calculation is your discount. So we could always use the same techniques with the strings as well. So for example, define get name. Name is equal to enter your name, return name. So you could return strings as well. You could also return multiple expressions. think we'll see that in the next few slides. And you could also return Boolean functions. We do know what a Boolean function is. It will either return true or false. So this is basically used for expressions. Let's say you are working with 10 is greater than or equal to 20. If that is true, then it is returning true. If it is false, it is returning false. So this is basically used to test as a condition for decision and repetition structures. We have already seen that decision structures and repetition structures are same as while loops and if else loops. So these are commonly used in calculations, such as whether a number is even can be represented by using a function as well. So while is invalid model, so you are basically validating the model number here in this example. So while is invalid, if that is invalid, print the valid model numbers are, and again you are getting the number from the data, that is from the user. So we are basically calling the is invalid function with model as your argument. So when you are defining your is invalid, you are checking, the statements are if module number is not equal to 100, and if it is not equal to 200 and not equal to 300, then the status is set to true. Else status is set to false. You are returning the status. So let's say the user has entered the number 400. So this 400, now your while loop is basically acting like an input validation loop, this block, and it is checking if that is valid or not. So when it is here, the interpreter will jump to the function part. And as the user entered number is not equal to 100, 200, or 300, then the status is set to true. So as this is valid model is true, the while loop will execute, because we do know that while will execute only if the condition is true. If the user has entered, let's say the number 100, then as 100 is not equal to 100, as this is false, so you are now jumping to the else block. The status is set to false, so this is false. So the input validation loop will not work, will not execute, because the user had entered a valid input. Okay. Now let's see the returning of multiple values. It will be the same syntax: return expression 1, comma, expression 2, comma, and so on and so forth. So commas are used to separate the expressions. And also when you are trying to call this call functions with multiple expressions, you must use the same number of variables on the left side of the operator as well. So in this example here, first is equal to enter your first name, last is equal to enter your last name. You are returning first and last names. So when you are calling this getName function, you should have two variables to accommodate the two expressions that you are going to return. First is equal to first, comma, last name is equal to getName. As getName is returning two variables, you must define two variables towards the left side of the argument. So in that case, the first name or the first variable will be accommodating the first expression that is returned. The second variable will be accommodating the second variable that is being returned. Next, we'll be talking about the math module. So this is a part of the standard library that contains functions. And as the name suggests, it is used for mathematical calculations. So it will accept one or more values as an argument, perform the operations, and then return the result. So for this, as this is not a standard library, it is not a complete part of the standard library, you are going to import the math module. So import math is a statement that you are going to use whenever you are trying to perform complex mathematical operations. So these are some of the operations that it can be used for: cos, sine, tangent, smallest integer, and then cosine. Then we have degrees, exponent, you have largest integer, hypotenuse, log base 10 logarithm, natural logarithm is this, and then radius, and then you have sine, square root, and tan. So if I ask you to perform or write a program that is basically performing a square root of the user entered input, then your first statement should be import math. Next is define main, and inside that you will be creating functions. Also note this, from this chapter on, every possible way you are going to introduce or you are going to use functions, even though you can write the program without using functions. I want you to do that so that you'll have a good practice. So the math module defines the variables pi and e, which are assigned to the mathematical values of pi and e. Pi is 3.14 and e is some value defined, which is already existing. I don't remember the value of e. So this is used when you are basically calculating the area of a circle, which is pi r square. So you could just use the dot notation to import or to use the function pi. So math dot pi or value pi. So math dot pi times radius 2 stars and then 2, that is exponent. So you could always include store functions in modules as well. This concept is also termed as modularization, which we have already looked at towards the beginning of this chapter. And then in large complex programs, it is important to keep the code organized. So modularization will basically make it easier for you to understand, test, and maintain. And it is easier to reuse the code as well. So a module is basically a file that will contains the Python code, and it has the extension .py. This is important. Like there can be an example, or there can be a problem where I'm asking you to create a module and then import that as your one of the modules in your program, and then use the functions that you have created in your .py file that you have just created as a module. So when we are discussing the problems, it will be much more clear. Okay. Menu-driven programs. So these are basically the programs where a list of operations are displayed on the screen, and the user will be selecting one option from those operations. So the such type of list of operations are also called as menu. So the program uses a decision structure. So that is basically an if and else structure to determine whether the selected menu option, what the selected menu option is, and then perform the required operation. So this will repeat until the user quits. So you should, like, let's say 5 is for quit, or enter Q for quit, something like that. You should ask the user to quit. Only then the program will quit. So this is the function display. So you have define, display menu, print menu. Your option 1 is area of circle, 2 is the circumference of the circle, 3 is area of rectangle, 4 is perimeter of rectangle, 5 is quit. So this will be the output on the screen, and depending upon the user's choice, you will be asking me, let's say the user has entered area of the circle. So in that case, you will be asking the radius from the user, because pi is already fixed and you can take that from the math module. So this is the execution example. You have the area of the that is menu, next area of the circle, circumference, area of rectangle, perimeter, quit. So the user has entered 1, you are asking the radius, and then the area is. It will again display, like after this execution is done, it is now going back and displaying the options. Next, the user will select a different option, it will again display. Next option display, it will only quit if the user has entered 5, which is quit in our case. So there can be a programming assignment question based upon this as well. So we'll also work on this on the lab as well. Okay, so this is the end of this topic, and the next topic will be turtle graphics using functions.